How much is that? How much?
1.8 calories per 100 ml.
Also, they have calories, but they don't have sugar. Right?
They have 1.8 per 100 ml.
So they're lying to you. They said 0 calories.
Yeah, but it's more than the no sugar. This no sugar one has like 3 calories per 100 ml. And this has 1.8. So like,
Still, lying. Both advertising.
by all
Laughing at my face now. Still early. Sorry about that.
What's wrong with this job?
3 milligrams of vitamin B6.
True, I didn't. I'll mention that later. Now we're working. Okay guys, listen up now. Hey, listen, we'll start now. So, we're starting now. So, earlier today we were looking at binomial coefficients. So far in sequence and series we've been looking at things like this, basically. So now we're going to move in a little bit of a different direction. So we're going to look more at a sequence. Last one we did was what now? Good. Right. So, guys, come on. Dude, come on. Right. So you remember at the start of the chapter I was saying that a sequence is like a list of numbers, and there's usually some formula to calculate the next term in the sequence. So for example, if you had a sequence like this, 1, 3, 5, 7, 9, 11, you can see what the formula is to calculate the next term. All you're doing is you're starting at 1, and then each time you're adding 2. So if you want to think about it as a rule, the rule is start at 1, then add 2 each time. So that's a very, very simple example of what a sequence is, okay? So if you can write this down as an example, please, and then we'll look at more difficult ones. Okay. So what about this sequence? We're starting at 1 and what's happening? We're multiplying by 2, aren't we? Okay, now, a little bit trickier to try and spot what's happening. What's happening in this sequence? It's not being multiplied. Yeah?
First we will add 1, then we will add 2.
That's it, yeah. You're adding 1, then 2, then you add 3, and then add 4, then add 5, then add 6. No, not that one, not that one. Okay, what about this one?
It's squaring the...
Each number is being squared, yeah, very good. So this would be 1 squared, 2 squared, 3 squared, 4 squared, etc. What about this one?
One times 2,
Think you have it?
3, 6, 1 to 4.
That's it.
1 to 4.
That's it. You spot it. Huh? Yeah, or also, it's this. 1 factorial, 2, 3, and 4. Okay, so we'll move on to something else, but just to give you one more example to warm up your brain.
Yeah, it is...
Yeah, no, I remember this one from school. It's my favourite one. So I'd be very impressed if anybody knows this one, because it doesn't look like it has any pattern. You know, go on and tell me, what is it? What?
How do you remember it from school?
What is it? Well, he knows, he says he knows.
No, I did, one...
So you think we will add them and we will put them on the list?
No, not adding.
What's the bunch?
Yeah, tell me.
It is one...
It's 1 first, yeah?
Plus 1, 3?
No, that's what... She just said that, and I told her no. Oh, fine. Yeah. Okay, I'll tell you what it is. I like this one now. It's more English one nearly than a maths one. So watch this. What you do is you write down the number 1 to start with. So you start with 1, and then you say what you have. So we have 1 1. Now what do we have? We have 3 1s. Now what do we have? We have 4 1s and 1 3. 1, 2, 3, 4. Now we have 7 1s, 2 3s, and 1 4. Oh, sorry, 6. And so on.
Again.
Say again. One more time, watch.
Yeah.
We write down 1 first, then we say what we have. We have 1 1. Now let's say what we have. We have 3 1s. Now say what you have. What have we got? We have 4 1s and 1 3. Now what do we have? We have 6 1s, 2 3s, and 1 4. Yes, that's it. Just like that.
But you answered. You just wrote the question again.
What? This is the rule. Don't worry, this one's not on the test, okay?
Yeah, I hope so.
No, I've spent too much time on it. It's not really one for the test. It was just one. The point I wanted to make with that last example was that the rule can really be anything, okay? So sometimes people think for sequence and series the rule has to be something like you always add a certain number or you always multiply by a certain number. But there are actually just 2 particular types of sequences. In fact, maybe some people know the names of these particular types of sequences. Ones that you get by adding and ones that you get by multiplying. Geometric is which one? Multiplying. And the one that you get by adding? Arithmetic. So these are only 2 examples of a sequence, but the rule can be anything, okay? So the first example here was just general sequences. What we're going to look at now is to give the rule as a formula, okay? So what I would call a sort of more direct or just by a formula. So for example, we usually use something like the letter U and N to represent a sequence. So U1, U2, U3, etc. That's the first, the second, and the third term. Come on, turn. Need something? No? So, no, don't worry. So, like in some places, I think maybe letter V is used, and some places might use the letter T as well. Oh, there, see? Don't worry. So, I use the letter U for a sequence, okay? But you can use the letter T, it doesn't matter. So this would represent the first term, the second term, and the third term. So for example, if you had the sequence 2, 4, and 8, you would say U1 is 2, U2 is 4, and U3 is 8 as an example. Yeah? Guys, come on, focus. So when you have it like this, you can give as a formula. So for example, here in this sequence 2, 4, 8, what's the next one? It'd be 16, for example, that's U4. As a formula, you could say UN equals 2 multiplied by n. So for example, if you want the first term, that's 2 multiplied by 1, which is 2. If you want the next term, 2 multiplied by 2, which is 4, and so on. So for example, here, what would be the 10th term? 2 multiplied by 10, which is 20 then, yeah? Yeah?
What about when
Huh? Yeah, so the third term, oh sorry, I wrote down the wrong formula, thank you. It's not 2, well maybe someone can offer to correct it, it's not 2 times n, I'm sorry. What is the formula, does anyone? I meant 2 to the power of n. Yeah, so the first term is 2 power 1, which is 2. The second term is 2 power 2, which is 4. The third term is 2 power 3, which is 8. So then actually, let's redo what I asked a moment ago. The 10th term is 2 power 10, 2, 4, 8, 16, 32. 2048, is it? Is it 2048? Yes, okay. Yes, okay. So let me give you a formula, and I would like you to tell me what the first 3 terms of this sequence is. So, for example, we have the formula, let's say UN, let's just say it's something like 1 plus 3n. So what I want to know is U1, U2, U3. What are the first 3 terms in this sequence? If you can calculate that, please. 1 plus 3n. Can you see? Yes? It's not 2048, it's 1024, is it? Yeah, I did 2 power 11 then. The previous one was 1024. Yeah, this one here, I want the first 3 terms. Yeah, this one's straightforward. So, here the first term would be 1 plus 3 times 1, which is 4. The second term in the sequence is 1 plus 3 times 2, which is 7. And then the third term is 1 plus 3 times 3, which is 10 then. Yeah, okay. Let's try another one now. Let me give you another example. So try this one. Again, the first 3 terms in this sequence. UN will say 1 plus minus 1 power n. Okay, give me the first 3 terms in that sequence. It's going to alternate, isn't it?
0. All 0.
No, not all 0. No. So the first term will be 1 plus minus 1 power 0, which is 1. The second term, when you type it in, will be
Minus what? No.
0.
Zero.
Is it? No, it's not. First term is 0. The second term is...
No, it's 0.
0.
Oh, it's 2. It's 2.
Minus 1 times 0.
Hang on, let's just write down. U1 is 1 plus minus 1 power 1, which is 1 minus 1, which is 0. U2 is 1 plus minus 1 squared, which is 1 plus 1, which is 2. And then U3 will be 1 plus minus 1 cubed, which is 1 minus 1, which is 0. So it's alternating between the two, 0 and 2. Okay. Right, now let's see. Let's try something else. So rather than the first three terms, give me something like the 10th term. So find the 10th term U10 in, and we'll say the formula for this sequence, we'll say it's UN equals, we'll go with something like 1 plus 1 over n, we'll say. Okay, so give me the 10th term here. We're getting there.
11 over 10.
Yeah, 11 over 10. So here, the 10th term is 1 plus 1 over 10, which will be 11 over 10, or some people might have it as 1.1 then. Yeah, that's okay. So far in all the examples I've given you, it's been kind of simple to calculate which what the term is. You just put n is 1 if you want the first term, n is 2 if you want the second term, n is 3 if you want the third term, and so on. So we're going to look at a different way to give you the formula, and I'll show it in the program as well. So for example, well, a little bit of vocabulary first. So if I have something like this, if I write the formula like this, this word here, is it? Recursive. Yeah. That's the name of this type of way to give the formula. So can anybody see what this formula is telling us, what the rule is here? No? Thank you for your brute honesty. Anyone else?
The term is Q plus Q.
That's it. What's happening here, remember what it stands for. So this represents the nth term, and this one would represent the next one, n plus 1th term. So this is the next term, and this is like the previous term, the term before it. What you're basically saying is that the next term, you get it by doing 2 plus whatever the previous one was, the last term. So it's basically a mathematical way of saying that you get the next number by adding 2 to the last number. And that's what recursive means. It's that the output goes back in for the input. Okay, we'll give an example. Okay, so for this sequence, we have to pick a number where to start. So we'll say for this sequence, we'll start at, let's say, 0, for example. So we know that x1 equals 0. The next term, so for example, x2, that would be 2 plus x1, which is 0. The next term is 2 plus x1, which is 2 plus 0, which is 2. x3, that would be 2 plus x2, which in this case would be 2 plus 2, which is 4 then. And then x4 would be 2 plus x3, which is 2 plus 4, which is 6. So what's happening is you need to know the last term before you can know the next term. You couldn't just jump straight to the 10th term. So recursive, that's the idea that when you have the answer, it goes back in again to make the next term. This is really what recursive means, okay? So this is a simple example where the next term is 2 plus the last term. Now I'll give you a simple one like this, and you can try and make the first few terms. So we'll say, as an example, we'll start at 2, and the formula is xn plus 1. We'll say it's 1 plus a half of the last term. Okay, so see what, give me the first three terms here. Yeah, let's see what we get then. So the first term I said is 2. So the second term is 1 plus the first term over 2, which would be 1 plus 2 over 2, which is 2 then. So what's going to happen here now? x3, that's 1 plus x2 over 2, which is 1 plus 2 over 2, which is 2. So in this sequence, what's happening? Nothing. It's staying fixed at 2. Yeah, we call it a constant sequence. That's what we say. Yeah, so this is an example of constant sequence. So I want to give you some vocabulary of different types of sequences in a moment. We've seen two types so far. Constant, which means it stays the same. And does anyone know the name of the one we did a moment ago where it switches between 2, 0, 2, 0, 2, 0? Does anyone know that one? No? No. What's a word that means repeating in maths? It begins with a P.
Repetition?
Say again?
Repetitive?
P. Begins with a P. Periodic. Periodic, yeah. I'll give you these words in a few minutes, okay? So we have a periodic and we have constant. Okay. I'm going to give you a sequence that's a little bit more difficult. I want you again to make the first, we'll say 5 terms this time. Can I scroll down? Yep. Okay, so for example, let me see, what one will we give? We'll give something like Vn equals, oh yeah, and just before I move on to that, just a little point worth saying. We write xn plus 1 on one side, and then on the other side was xn, where this represents the next term, and then this one was the last term, the previous term. But there are slightly different ways to do it if you want. For example, if you put xn here, and you want that to represent the next term, then what should I write here to represent the last term? xn minus 1 then, okay? So just take care with that in the exam, because they'll use one or the other. So I think I probably would mostly use that, but this is also common for the exam. Okay, so now on to the example. We'll say xn plus 1 equals 1 plus 1 over xn. So far it looks like the same as the last one. Well, it's a bit similar to it. And we'll start with 1. Okay. So I want you to give me the first 5 terms. The answer will be a decimal. You can leave it as a decimal or a fraction. And you can do this on your calculator. So first 5 terms. So you already have the first one there. So x1 is 1. Get the next 4. Okay. Right, so I can see the next term is 2. So then x3 will be 1 plus 1 over 3, which is 4 over 3. x4 will be 1 plus 1 over 4 over 3. That's 3 up 7. Oh, sorry.
It is
3 over
1
Thank
over
you.
4.
and that one is
It's 1.1/2.
Ah, yeah. 3 over 2. Thank you. Then x4 is 1 plus 1 over 3 over 2, which is 5 over 3. And then lastly, x5 is 1 plus 1 over 5 over 3. What's that? 8 over 3? 8 over 5. As decimals, this would be 1. This would be 2. This would be 1.5. This would be 1.67. And this would be 1. No, hang on. 5. 3/5. 1.6, is it? 1.6. Is this right? 1.67? Yeah, it is. Yeah. Yeah. Did you get these as well? Yeah. So you can see that if I asked you, oh, what is the 20th term, then you need to go up to 20, starting from 1. So this is something ideal for Excel, because in the ICT last week I was showing you how to type in a formula. So what's the first term in this sequence? Let me just expand this a little bit. Where did I tell you to start here? Was that 1, wasn't it? So let's type in the formula in Excel. Here I should type in equals. What should I type in? If I want to make the next term. 1 plus 1 over A1. Because A1 is the value we have. So this should make the same number, which is 2. And what was the next one? So if I copy this down, I can make them quite easily. So we'll go to 100. Now I want you to notice something that's happening with this. Listen, I want you to notice something that's happening with this sequence. You can see that it very quickly moves to about 1.61. And once it gets there, it doesn't change its value too much. Do you see that? And in fact, here you can't see it because there's not enough decimal places. Oops. Nope. No, oh, there we go. Yeah, there's a bit more decimal places here. Yeah, you can see that. I don't have enough decimal places. It's changing still, but the changes are becoming really, really small. So what's happening in this sequence is it's like it's moving towards a certain value. Yeah, does anyone know the description of that sequence? Not exponential? Yeah, give me a word for that. Begins with C. No. So a sequence like this that appears to be approaching a number but doesn't quite get there, but practically does. This is called Convergent. Oh yeah. Convergent. Yeah. What? Did you know this?
No.
Right, so Convergent, what we say is it's trying to reach what we call a limit. The number that it's trying to get to here is called the limit. So, convergent sequence, yeah. So we'll say it's moving to a limit, we call it. And I'll just give you the words we had earlier. Periodic, that means the sequence repeats. And then the other one, of course, is constant. That means it does not change. Periodic means it could be switching between two numbers, like it goes 0, 2, 0, 2. Oh, it doesn't have to be two numbers, it could be like 1, 2, 3, 1, 2, 3, 1, 2, 3 would be periodic. So the next one I want to do is divergent. So now that you have these words and you might remember convergent, does anyone remember what divergent is from school? So basically it's the opposite of convergent, isn't it? So the simplest way to say divergent is just really not convergent. Which then kind of makes these sequences, this sequence here, divergent as well, because it also is not moving towards a number, it just keeps jumping around. But in the exam, they don't really expect you to be that particular with the language. In the exam, you'll be expected to know these 4 words: a convergent sequence, a periodic sequence, a constant sequence, and a divergent sequence. So I want to give you an example of a divergent sequence, recursive formula. So again, give me the first 5 terms of this sequence. We'll say x n this time to make it different. We'll say is 2 times x n minus 1, and we'll start with the first term. We'll just make it 1. Okay, so give me the first 5 terms of this sequence. Yeah. So the first term we said is 1, the second term 2, next one 4, 8 and 16. Okay. So let me just go back to Excel just to look at that. We'll have Excel make the terms for us. Okay, whoops, right. So here we started at 1. Now this time actually what I want to do is I'm going to have Excel use this formula. And I'm going to make OR equal to, in my example, 2. So I'll just write the OR here. Okay, so the first term we said to start at was 1, and then the second term is 2 times the last term, or in this case, OR times the last one. And because the OR, we want to keep it fixed in the formula, what do we need to do? Does anyone remember?
Reference.
No. Yeah, well, how do we fix something in a formula to not change? The dollar sign around it. So the next one is 2, and then we go all the way up, let's say, to the 13th term. So you can see this is divergent. It's moving away from a limit.
Do we have to use like this absolute difference in every single digit?
The dollar sign?
Yeah, absolute difference.
When a part of the formula is not to change, you need to use the dollar sign.
Okay.
So like constant or something. Now this sequence here, let me just hide this one here from earlier. Right, so this is our sequence, and you can see that it's divergent, so it's getting bigger and bigger. But what if I was to change the value of 1? If I make it say 0.5, the whole thing changes, and it still diverges, doesn't it?
Yeah.
So let me just put it back to 1. And what about the OR? If I change this OR to say 3, will it diverge? Will it grow quicker or slower? Will it change faster or slower? Quicker, because you're multiplying by 3. So you can see now it's diverging faster. And then if I did 4, you can see even more. But what about if I was to change the value of OR? Like if I made it 0.5. So what are you doing each time? Each time you're multiplying by a half. And what happens then? It makes it smaller then. So, will it? Let's see. Now it's convergent. Each time it's getting smaller and it's trying to run down to 0. Can you see that?
Yeah.
So by just changing the number you're multiplying by, it's now moving towards 0. This means,
How about
that just means that's 10 power minus 5.
how about negative 1?
Yeah, what happens if we have minus 1? So each time we're multiplying by minus 1. So what happens, now what type of sequence is this? Periodic. What would I need to make the OR so that it's a constant sequence? If I want the sequence to be constant. Yeah, 1. What will I get? Oh, just 1. Because each time you're multiplying by 1. So nothing is changing. Yeah. So we've seen in this one an example of convergent, divergent, periodic and constant. So even a sequence as simple looking as this, you can get different behaviors. So for example, in this one, when the OR is bigger than 1, what happens? Do you remember? It diverged. And when the OR was equal to 1, it's constant. If the OR is equal to something which is bigger than 0 and less than 1, like a decimal, then what was that? That was convergent. And then if OR equals minus 1, what one was that? That was periodic. And what about if OR is less than minus 1? If it was like minus 2? Diverges. Yeah, let's show that as an example. If I put in OR as minus 2, it's divergent, and it's actually even strange. It's divergent, but it's also switching between plus and minus as well as it moves away from 0.
Isn't it periodic? Switching?
Yeah, but for periodic it has to be the same numbers. Yeah.
But you just could be like 1, 2, 3, 1, 2, 3.
Yeah.
Okay.
You realise what you were saying as you said it, yeah? Okay, let's have a look at one more example. Dala,
Yes?
what am I going to say?
What are you going to say? No idea. You don't want to say?
Focus. Yes. I can't, I'm all out. Right, now, let me give you another example. This one is a little bit more difficult because in this formula it depends on the previous two. So what I mean here is, I'll tell you that the first term is 1. I'll also tell you that the second term is 1. And to get the next term is equal to the last term plus the term before that one. So you're looking at the previous term and the one before that as well. So again, give me the first 5 terms here, see what you can make. Okay, so what is the third term here? Yeah, it's the last one plus the second last one. And the fourth term would be the last one plus the second last one. And then the fifth term would be the last one plus the second last one. So this would be 5. Let's do one more. What would be the sixth term? That would be 5 plus 3, which is 8. Yeah. So this one here, it depends on the previous two. So what type of sequence is this? Convergent, divergent, constant, or periodic? Divergent. It's not moving to any limit. Yeah. Okay. Now I should also say your maths coursework 1 is going to be about this topic, this particular lesson. Okay. So you're not, if I look here at the topics that are coming up, you don't quite have enough maths yet to do the assignment. You have enough to get it started, but not enough to finish it. So I'd say by the end of the next chapter is when I'll give you the assignment, and then you'll have 2 weeks to work on it. But this is like the first lesson, which is about the assignment. So this lesson and until the end of the next chapter, all those topics is what the Maths Coursework 1 is about. Okay?
Next chapter.
Yeah, so like this chapter and then the next chapter.
And then the last chapter was algebra.
The algebra is not really part of Coursework 1. It's the sequence and series chapter from this lesson onwards. Not the previous stuff, just this lesson. And then pretty much all of the next chapter. And the next chapter is actually pretty small as well. There's only 5 lessons in
the
it.
actual assignment is this class plus the next chapter.
This class plus the next few.
So
Yeah.
algebra is just basics.
Yeah. I mean, there'll be some algebra in it, of course, but the whole idea of the assignment is about this one, okay? So it's actually important for your coursework that you're clear on this lesson, because this is the first lesson in the coursework then. Yeah. Now, I'll give you some questions that you can start working on now from both worksheets. So from this one, let's see. They're pretty short questions. So ABC for this one.
ABC from your question?
ABC, yeah. And then from the one earlier today, so listen, from the one earlier today, I want you to do A in each question. Except for number 3, I also want to see you try to do I. So it's A and I, A. Yeah. So A in everything except number 3, which is A and I. Okay. That's from earlier today. And the one for right now is ABC for each. Yeah?
Yeah, the second one's pretty easy.
This one you should get it done. The first one is A in everything, except the number 3, which is A and I. Okay, can you start working on those now, please? Yeah?
On the ones from the previous.
Whichever you prefer, but this one, since you're doing it